So this is for the Unit 6 test. We're almost there, one more unit before we start doing reviews. So the biggest thing that I could say between the quiz and the test is make sure you've completed, understood, and can do again all correctly all this Unit 6 daily lessons, homework, and free response questions. The best way to study this is, one, make sure that you do your homework in the first place, but let's say that you didn't, or you did it quickly, or you looked at solutions and kind of got to the answer, try doing them again. There are multiple choice questions in there that look like multiple choice from a test. That's a pretty good guess that they're going to be multiple choice test questions. There are free response questions all throughout. Any one of those could be your free response on the test or quiz. So make sure that you're looking through those. Wow, actually not even just looking through, but making sure that you could do them again on your own. So try them. If you're not confident that you could, do them again. Study tests or the quiz 10 and quiz 11, so look over your answers, make sure that you understood everything. If you made any mistakes, that you won't make those again. So any of these concepts still fair game for the unit exams, because that is pretty much what the unit was about. Okay, so the other things that will definitely be on your tests, and I'm just reading this straight from your review sheet. So calculating the definite integrals by finding the area of the curve or by using the fundamental theorem of calculus. What that means is if you are given, let's go back to this. Let's say you are given something like this. You're given a graph of f prime of x. So you've got f prime of x, something, some type of graph, doing something, I don't know. How do I find the integral from a to b of f prime of x? These match up. All you're doing is finding the area under the curve. If you were given, instead of this being f prime of x, if this were f of x, then you would have to think, oh, okay, well, I know this is the fundamental theorem of calculus, right? F of b minus f of a, because f of x is an antiderivative of f prime. So I just go and look at the points on here, whatever f of b is, whatever f of a is, and then subtract. There are going to be other ones that it's saying find the average value of a function involving integrals. So what I mean by that is you'll be asked a question like you've got some function equals whatever it is, sine of x plus x squared plus 3. I have no idea. And you want to find the average value of that function. To find the average of any function, I take an integral from whatever a to b I'm talking about. I'm going to do 1 over b minus a, but integrate f of x. Remember, integration will take you back to its antiderivative, like f of b minus f of a, whatever that amount of change is. But this b minus a takes you back to whatever the units were for f of x. So we're talking about an average rate of change, well, I should say average value of the function. If I wanted average rate of change, then I'd just do f of b minus f of a over b minus a. Average velocity or acceleration. So let's say this was v of t instead of f of x. If I wanted to find average velocity, I would do the same thing. If I wanted to find average acceleration, but I was given velocity, I would have to do the v of b over v of a, or v of b minus v of a over b minus a. So let's say I'm given velocity in some way. I don't know what it is. Some equation, some graph, whatever it is. And I want to find the average velocity. I would have to do 1 over b minus a, integral from a to b. If I wanted to find the average acceleration, this is what I would do, v of b minus v of a. And use your units to help you on this. Let's say velocity was given in meters per second. If I integrate this, I would go back to meters, but this b minus a would be a to b seconds, so I get meters per second. This right here, if I'm talking about average acceleration, this would be meters per second, which is the units for average acceleration, meters per second squared. So just be careful, use your brain, make sure that you're checking units and making sure that your answer and your process makes sense. Okay, so your knowledge of properties using definite integrals. So anytime, let's say problems like this, I know by the properties of integrals that I can split this up. The antiderivative, well, actually I don't even need to do that because this is given as 2a plus 3b. Over here, the antiderivative of 4 is 4x, or an antiderivative from a to b. F of b minus f of a, so in this case I would have 4b minus 4a. And then I can combine like terms, so 7b. You're using properties of integrals. When you're finding the area under the curve, I can find the area of one part and add it to another one. So if I have, I don't know, 2 to 5, and I've got some graph, 2 to 5, and I have a triangle, and then I've got a circle, or a semicircle, I can figure out the area of this part plus the area of this part. Okay, I need to check on my son. 1 second. He's actually doing okay right at this moment. Other things you want to do. Oh, never mind. My husband's going to get them because he's really nice. So if I go through the rest of this, if I am understanding the derivative as a rate of change and the integral as an accumulated amount of change. So for instance, if I take something like this, so let's say I've got some function f of x, and I have some equation to go with it. I know I'm really being specific, but the final units were in backpacks per year. If I integrate f of x, excuse me, if I integrate f of x from, let's say, 0 to 5, what this would tell me is that if I integrate this, I'm going back to an antiderivative. If this is given in backpacks, then this capital F would be f of 5 minus f of 0. What this would give would be amount of change of backpacks. From years 0 to 5, or whatever units this would be. Yeah, this is years. So from year 0 to year 5. So the amount of change in backpacks. If I would change this slightly, and I would say this is 1 over 5 minus 0, this is no longer the amount of change in backpacks because I've got this 5. The numerator is still the amount of change in backpacks over 5 years. So this is the average rate measured in backpacks per year for 5 years. So someone asked me about this earlier to kind of give some basic units. So let's say I've got some function f prime of x, and that was given as meters per second. If I integrate that, my unit is just going to be meters. If I took this and did 1 over b minus a, as long as I did from a to b here, of the integral of f prime of x, I'm going to come back to meters per second. If I took, let's say f prime of, I don't want to make it too confusing with b, let's do this, just do f double prime. This would be the derivative, so meters per second squared, or meters per second per second. So lots of different options here. Just make sure that you know these connections between them. Okay, the derivative is a rate of change, and it's at a particular moment of time. If you're doing an average rate of change, that's going to be the slope of the secant. Remember that just at a moment, it would be the slope of the tangent. Accumulated amount of change. So this is like the f of b minus f of a. It's the amount of change that happens over a unit of time from a to b. And this one, oh, your ability to use a chart, graph, or equation of a rate to determine a function value. This is like the ones like that might give you one function value and then ask for another one. You had a whole lot of homework assignments on these, or homework problems, so make sure that you go back and look at those. Lots of people have been asking me questions in the last week on those, so just make sure you see ones like that and check them out, where you have to do the area under the curve because you're given a graph of f prime, but you have to figure out f of x. This one gives a specific example, so 170 to 172. Go back to look at those problems. Riemann sums, if you're not very good at them, you had a whole lot of practice ones to do in your homework. Try them. And whether the selected, if you're talking about if a Riemann sum is an overestimate, underestimate, or accurate estimate of the actual area, this would be one like, let's say, you know, a function is increasing and concave down. If you had a right Riemann sum, I can see it's going to be an overestimate. But if I have a function that's increasing and concave down, meaning the first derivative is positive, the second derivative is negative, and I had a left Riemann sum, you can see it's going to be an underestimate. So really, it's just drawing those things on there. The same thing with the trapezoidal. It would be a slight underestimate. Draw them. Don't draw very many rectangles, because the fewer rectangles you could draw, even if it was just one, like here, let's say a left, it becomes really obvious that it's an underestimate. The other questions on here, it says problems involving two integrals are similar to free response questions. Two integrals, meaning like the snow is melting, sand is being added or taken away. There's a whole lot of problems like this. I think water was flowing into a pipe on one and flowing out of a pipe. Lots and lots of problems like that. I said, oh, there was one in our notes about people going into a concert and then how many people are there. Lots of questions like that. There's also things with the connections between position, velocity, and acceleration. So make sure that you're doing this. How to use derivatives and integrals to calculate or estimate the values of each given a chart, equation, or graph. So if you're given velocity, how do you get back to position? You take the antiderivative. If you were given velocity and you want to find acceleration, what do? You take the derivative. So a lot of that stuff. As I'm looking through just on the calculator permitted, you have to know how to take antiderivatives in your calculator for definite integrals. Yeah, there's things like on your homework, on your quiz. If you are given any sort of rate, but you want to know the amount of something, make sure you know how to integrate. You have to know how to do Riemann sums given a chart. Yeah, a lot of this you just really have to know. I know that on the calculator permitted, this one takes longer than other ones. Like, people, make sure that you're coming into the classroom ready to work right away, because most people are pushing it for time, and I'm going to be on your case to finish this in time. So this is on the calculator permitted one. I said, make sure you know this. It's really going to be obvious if you haven't practiced problems like that, because you're going to want to take a lot longer, and I'm going to be kicking you out of the room. On the non-calculator test, you really just have to know your stuff as far as integrals are concerned. When to take a derivative, when to do the integral, when to do the area under the curve, when to use the fundamental theorem of calculus. Don't forget about initial values. So let's say you're trying to find the amount of water in a swimming pool. Make sure that you figure out how much water is there initially. And then I think that's about it. I think that I don't want to give too much more away, because if you are doing your homework, if you are doing the free responses and doing the work that you need to be doing, and studying and making sure you've got this, I think you should be pretty good. So if you're on a trip to Disney, I hope you're having a fantastic time and not stressing out too much, but also not forgetting about work entirely. I will see you when I see you. Happy studying. Bye.